ABHISON's mastery lies in the design and manufacturing of high-quality curing chambers. The hydrosetting process, commonly known as curing, is one of the most important processes in the lead-acid battery manufacturing. While it is widely accepted as an important process, it is also least understood, which results into the generalization of curing process and in turn the generalization of curing chamber. The selection of the curing process parameters and chambers without understanding the complexity of the curing process can lead to the generation of crystalline structure not suitable for the performance of the final battery produced in the field. Hello everyone, my name is ABHISON and in today's session I will be talking about the complexity of curing process, how to design a curing process, and how to identify a good curing chamber. So let's get started. While it is widely acknowledged that curing is the most crucial step, it is also often misunderstood. And why is that? Many people think that curing is a generalized process, believing that as long as the temperature and humidity are maintained, the plates are to be taken out. But this isn't the case. Curing is a much more complex process and it requires a fine control and clear understanding over various parameters to ensure the performance of the battery. So let's dive deeper into this and get into the details. The curing process parameters such as temperature and humidity vary based on the crystalline structure composition required in the final active material of the battery plate, and the active material composition should be solely dependent on the application of the finished battery product. For example, the active material composition or crystallization in the SLI batteries will be different from that of the stationary batteries. In SLI batteries also, the composition will be different or can be designed differently based on the application. For example, the starter batteries in automotive will have a different composition than a starter batteries in the boat where the vibrations are comparatively lesser. And now we will see how the active material composition is determined. The composition depends upon the ratio of tetrabasic and tribasic crystallized structure. Specifically, the ratio between the tetrabasic and tribasic crystallized structure dictates its properties and consequently the most suitable application for the finished battery product. Thus, by understanding these ratios, we can design the batteries that meet the specific demand of various applications. During the curing process, the temperature plays a crucial role in determining the type of lead sulfate crystals that form within the active material. At lower temperature, tribasic lead sulfate crystals are formed. At higher temperature, large crystals of tetrabasic lead sulfate crystals are formed. By setting a proper uniform temperature during the curing process, you can effectively control the ratio of tetrabasic and tribasic crystal formation. And this control is essential for achieving the desired properties within the active material, ensuring that the batteries meet the specific performance requirement. The tribasic lead sulfate, known as 3BS, converts to beta lead peroxide during the charging process of battery manufacturing. Similarly, the tetrabasic lead sulfates convert to alpha lead peroxide. The 3BS crystals determine the charging and the discharging capacity of positive active material. But its amorphous and fine nature of the crystal can negatively affect the life of positive active material. The 4BS crystals determines the life of the active material because of its bigger size and harder nature of crystal structure. A good designer can easily get the desired performance in the battery by selecting or changing the ratio of 3BS and 4BS. Coming to the next point, how to design a curing process. The first step is to determine the application of the finished battery product. Secondly, based on the application, you should design how much proportion of tetrabasic and tribasic ratio is required. The third step is to set the parameters, and finally you need to select an efficient curing chamber. So how to identify a good curing chamber? A good curing chamber is the one which can efficiently bring the tetrabasic and tribasic ratios to the level as designed by your process engineer. This ensures that the curing process produces optimal active material composition for the intended application. Thus, a good process designer first designs the crystalline structure required as per the application of the battery, And once this ratio is fixed, ABHISON's curing chamber are well equipped to achieve the required combination of tetrabasic and tribasic crystals because of our fine and uniform control over various parameters. So this is it for this video. Thank you so much for your time and attention. If you have any queries or would like to know more about our curing chambers or any other products, feel free to contact us anytime. In the next video, we will be talking about the features of ABHISON's curing chambers. So stay tuned. Thank you so much once again.